Welcome to all.
Prepared by Group A. Class 8. Subject Math. Topic PPT on Math Album. Great Mathematician. Aryabhata. Great Mathematician. Ramanujam. Great Mathematician. Pythagoras. Pythagoras Theorem. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Example, a 3, 4, 5 trianglia has a right angle in it. Let's check if the area's area the same, 3 square plus 4 square equals 5 square. Calculating this becomes 9 plus 16 equals 25. Linear equation in one variable. 1. An equation is a statement of equality of two algebraic expressions involving one or more unknown quantities. 2. An equation involving only a linear polynomial is called a linear equation. For example, 2x upon 5, 4 equal to 1 upon 2 minus t plus 7 upon 3, 3x plus 2x equal to 33.
3. Any value of the variable which makes the equation a true statement is called the solution or root of the equation. For example, minus 2 is root of the equation 3x minus 2 equal to minus 8.
4. Any term of an equation may be taken to the other side with its sign changed without affecting the equality. This process is called transposition. For example, 2x plus 9 equal to 17. Then 2x equal to 17 minus 9 equal to 8. Then x equal to 8 upon 2 equal to 4. Therefore, x equal to 4. Cross multiplication. If a x plus b upon c x plus d equal to p upon q, then q multiply by a x plus b equal to p multiply by c x plus d. This process is called cross multiplication.
Rational numbers.
Natural numbers. What is natural numbers? Natural numbers, the counting numbers which are begins from 1, is called natural numbers. Example: 1, 2, 3, 4, etc.
What is whole numbers? Whole numbers. All natural numbers together with 0 are called whole numbers. The collection of whole numbers is denoted by W, that is, W equals 0, 1, 2, 3, 4, etc. Integers. Whole numbers together with negative natural numbers are called integers. The collection of integers is denoted by Z, that is, Z equals minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. What is rational numbers? The numbers of the form p upon q, where p and q are integers, and q not equal to 0 are called rational numbers.
Properties of rational numbers. 1. Rational numbers are closed down to the operations of addition, subtraction and multiplication. 2. Rational numbers are commutative under the operations of addition and multiplication. 3. Rational numbers are associative under the operations of addition and multiplication.
4. The number 0 is the additive identity for rational numbers. 5. The number 1 is the multiplicative identity for rational numbers. 6. The additive inverse of the rational number upon b is minus a upon b.
7. Multiplication is distributive over addition and subtraction of rational numbers. That is, for any three rational numbers a, b and c, a multiply by b plus c equal to a multiply by b plus a multiply by c, and a multiply by b minus c equal to a multiply by b minus a multiply by c. 8. Between any two given rational numbers there are countless rational numbers.
9. There are two methods of finding rational numbers between the two given rational numbers. First method. Add the two rational numbers and divide the sum by 2 to get a new rational number. The rational number so obtained will lie between the given ones. Note that here we get 3 consecutive rational numbers. B. To get another new rational number, divide the sum of any 2 consecutive rational numbers, obtained in above step, by 2. C. Repeat the above step as many times as per requirement of finding rational numbers between 2 rational numbers. Second method. A. Convert the denominator of both the fractions into the same denominator by taking LCM. B. Find the different values of integers which lie between the numerators of the 2 rational numbers having same denominator. C. The required rational numbers are obtained by taking the integers found in step 2 as numerator and keeping the denominator same as the LCM. D. If the new fractions do not have any number in between the given numerator, then multiply numerator as well as denominator of both the fractions by a suitable number and then find the rational numbers between them. Properties of rational numbers with example. Closure property. Under addition. When 2 numbers are added, their sum is always a rational number. For example, 5 upon 6 plus 4 upon 5 equals 49 upon 30. 49 upon 30 is also a rational number. Therefore, rational numbers are closed under addition. It means for any 2 rational numbers a and b, a plus b is also a rational number. When 2 rational numbers are subtracted, the result is always a rational number. For example, 3 upon 4 minus 2 upon 3 equals 1 upon 12, which is also a rational number. Therefore, rational numbers are closed under subtraction. It means for any 2 rational numbers, a and b, a minus b is also a rational number. Multiplication. When 2 rational numbers are multiplied, their product is always a rational number. For example, 4 upon 11 multiplied by 3 upon 7 equals 12 upon 77, which is also a rational number. Therefore, rational number are closed under multiplication. It means for any 2 rational number a and b, a tilde b is also a rational number. Division. As for any rational number r divided by 0 is not defined. Therefore not all rational numbers are closed under division. We can say that except 0, all rational numbers are closed under division. Take a look at some examples of division of rational numbers. 5 upon 7 divided by 3 upon 8 equals 5 upon 7 multiplied by 8 upon 3 equals 40 upon 21, which is a rational number. Example 2. Minus 4 upon 5 divided by minus 6 upon 7 equals minus 4 upon 5 multiplied by 7 upon minus 6 equals 14 upon 15, which is a rational number.
Commutative property.
Addition is commutative for rational numbers. In general, for any 2 rational numbers a and b, a plus b equals b plus a. The following examples prove the commutativity of addition for rational numbers. 3 upon 7 plus 5 upon 7 equals 8 upon 7. 5 upon 7 plus 3 upon 7 equals 8 upon 7. Minus 4 upon 9 plus minus 7 upon 9 equals minus 11 upon 9. Minus 7 upon 9 plus minus 4 upon 9 equals minus 11 upon 9. Multiplication. Multiplication is also commutative for rational numbers. In general, for any 2 rational numbers a and b, a multiplied by b equals b multiplied by a. The following example prove the commutativity of multiplication for rational numbers. 2 upon 7 multiplied by 5 upon 9 equals 10 upon 63, and 5 upon 9 multiplied by 2 upon 7 equals 10 upon 63. Subtraction. Subtraction is not commutative for rational numbers. In general, for any two rational numbers a and b, a minus b not equal to b minus a. Look at the following example showing that subtraction of rational numbers is not commutative. 5 upon 6 minus 2 upon 3 equals 1 upon 6, but 2 upon 3 minus 5 upon 6 equals minus 1 upon 6. Division. Division is not commutative for rational numbers. In general, for any rational numbers a and b, a divided by b not equal to b divided by a. Look at the following example showing that division of rational numbers is not commutative. 8 upon 11 divided by 4 upon 5 equal to 10 upon 11, but 4 upon 5 divided by 8 upon 11 equal to 11 upon 10.
Magic squares. Comparing quantities.
1. Percentages are numerators of fractions with denominator 100. The symbol percent is used for percent and it indicates multiplication with 1 upon 100. 2. Percentage increase or decrease equals amount of charges upon original amount multiplied by 100. 3. The price at which an article is purchased is called the cost price, CP. 4. The price at which an article is sold is called the selling price, SB. 5. If SB greater than CP, then a profit is made. CAN equals SB minus CP. 6. If SB smaller than CP, then a loss is incurred. Loss equals CP minus SB. CAN percent equals CAN multiplied by 100 upon CP. Loss percent equals loss multiplied by 100 upon CP. 7. Discount. In order to give a boost to the sales of an item or to clear the old stock, articles are sold at reduced prices. This reduction is given on the marked price MP of the article and is known as discount. Discount equals MP minus SB. Discount percent equals MP minus SB upon MP multiplied by 100. 8. Sales tax or value-added tax. VAT is charged on the sale of an item by the government and is added to the bill amount. Sales tax equals tax percent of bill amount. 9. Whenever we borrow money from some lending sources such as banks or financial institutions etc., we have to pay some extra money for the service of lending. This extra money depends on the sum we borrow and the period of time for which we borrow. This extra money is called the interest. 10. The money borrowed is called the principal or sum. 11. Amount equals principal plus interest. 12. Interest on rupees 100 for 1 year is called the rate percent per annum. 13. If the interest is calculated uniformly on the original principal, it is called the simple interest. 14. If PRT stand for principal, rate and time respectively, and SI stands for simple interest, then SI equals PRT upon 100. 15. Compound interest. Compound interest is the interest calculated on the previous year's amount. Visualizing solid shapes. 1. The circle, the square, the rectangle, the quadrilateral, the triangle are examples of plane figures. The cube, the cuboid, the sphere, the cylinder, the cone, the pyramid are examples of solid shapes. 2. Plane figures are of 2 dimensions 2D and the solid shapes are of 3 dimensions 3D. Examples. 3. Each side of a solid has a surface called a face. 2 faces meet at a line segment called an edge. 3 edges meet at a point called a vertex. 4. 3D shapes have different views when seen from different positions. 5. Polyhedron is a solid figure bounded by plane polygonal faces. 6. A polyhedron with all its faces as regular polygons is called regular polyhedron. 7. Prism is a polyhedron with 2 parallel opposite faces called bases, that are congruent polygons, and the lateral faces are parallelograms. Pyramid is a solid whose base is a plane rectilinear figure and whose side faces are triangles having a common vertex, called the vertex of the pyramid. Euler's formula: for any polyhedron, F plus V equals E plus Q, where F equals number of faces, V equals number of vertices, E equals number of edges. Crossword puzzle. Playing with numbers.
1. A number is said to be in a generalized form if it is expressed as the sum of the products of its digits with their respective place values. 2. The general form of a 2-digit number of b can be written as a b equals a multiplied by 10 plus b multiplied by 1. Where is any whole number from 1 to 9 and b is any whole number from 0 to 9.
3. The general form of a 3-digit number ABC can be written as a BC equals a multiplied by 100 plus b multiplied by 10 plus c multiplied by 1. Where is any whole number from 1 to 9, b and c are any whole number from 0 to 9. 4. The sum of a 2-digit number and the number obtained by reversing the digits is always divisible by 11. 5. The difference of a 2-digit number and the number obtained by reversing its digits is always divisible by 9. 6. The difference of a 3-digit number and the number obtained by reversing its digits is always divisible by 99. 7. The general form of numbers are helpful in solving puzzles or number games. Divisibility rules. 8. Just for divisibility by 2, a number is divisible by 2 if its unit place digit is 0, 2, 4, 6 or 8. 9. Just for divisibility by 3, a number is divisible by 3 if the sum of its digits is divisible by 3. 10. Just for divisibility by 4, a number is divisible by 4 if the number formed by its digits and tens and units place is divisible by 4. 11. Just for divisibility by 5, a number is divisible by 5 if its units digit is 0 or 5. 12. Just for divisibility by 6, a number is divisible by 6 if it is divisible by both 2 and 3. 13. Just for divisibility by 8, a number is divisible by 8 if the number formed by its digits in hundreds, tens and units places is divisible by 8. 14. Just for divisibility by 9, a number is divisible by 9 if the sum of its digits is divisible by 9. 15. Just for divisibility by 10, a number is divisible by 10 if its units digit is 0. 16. Just for divisibility by 11, a number is divisible by 11 if the difference of the sum of its digits in odd places and sum of its digits in even places starting from units place is either 0 or a multiple of 11. 17. If two numbers are divisible by a number, then their sum and difference are also divisible by that number. 18. If a number is divisible by two coprime numbers, then it is divisible by their product also. Thank you for watching Group as Math presentation.